Welcome back guys, this is Ashwin here. In this video we are going to see about how to insert an element at the end of singly linked list. So in the previous video we have seen how to insert at the beginning of the linked list. So now we are going to see how to insert at the end of the linked list. So here we will be having multiple cases. So we will be checking few conditions and after that implement the logic based on that particular condition. So we will see what are the cases and how the whole process works. Let's see all this with an example. So first I will specify the element that needs to be inserted. That will be D equals 3. This is the element we want to insert. So first case 1. So the first case is what happens if the list is empty. List is so the first case is list is empty. So what we'll be doing is we will be creating a new node. So the new node won't be having any pointers to the next. So this will we can slash it and it will be having the element 3. This is the new node we have to create. And what we are going to do is assign this new node to the head pointer. Head. So this is when the list is empty, we have to do this operation. So we'll be initializing the node with the element we have to insert, and after that assign this new node to the head pointer. So this is case number 1. The case number 2. So case number 2 obviously will be list has some elements. List has elements. I am going to create a linked list of size 3. So let me create that quickly. So I have created 3 nodes. I will place some elements now. So this will be 4, this will be 1, and this can be 5. So it will be connected to each other. And the last element will be null. So this last node will be pointing to the null pointer, and this will be the head pointer. So this is head. Now I will just replicate the same linked list and will show you how this works. So now in this case we can't able to make use of this head pointer, because if you change the head means it will we can't able to traverse from the start again. So what we are going to do is we are going to create a temporary pointer. So temporary pointer. So this head pointer will be pointing to this temporary pointer. Now what we are going to do is we are going to traverse this temporary pointer until we reach the end of the list. Now temp will be here. Now temp is here. Now we will try to initialize the new node with the element 3. So this is the new node with element 3. What we are going to do is, after we have traversed to the end of the linked list, we are going to assign this pointer to this node. So I will just erase this one. So I'm going to erase this null value, and the next pointer will be pointing like this. So we have created the new node and inserted at the end of the linked list. So in this case we have traversed to the end of the list with a temporary variable, and after that we have assigned the next pointer of the last element to the new node. And finally we will return this head pointer. We didn't change anything to this head pointer, so we will just return as it is. So this is case 1 and case 2. For this, the time complexity will be, so time complexity is order of n. So for inserting at the end, what we are going to do is we are going to traverse all the elements, right? So currently here n is 3. That is the length of the linked list. So we have traversed all the 3 elements, and we have done this operation. So for this traversing only, we are having the order with big O of n. That's how the time complexity here works. And we have seen both the cases. Now let's see how the algorithm works. Now let's mention the parameter names. Head equals head pointer of linked list, and the next thing is D is element to insert. Now let's go to the algorithm now. Now algorithm insert at end with the parameters head and D. Now for both of these cases, we have to initialize the new node. So initialize new node equals node of D. That is the element we have to create. So this statement will create a new node like this. Now let's make the code for the first case. So I'll just comment this if list is empty. So for this we have to check for the condition if head equals null, then we have to assign the new node to the head pointer. So head equals new node. After that we can able to return the head pointer. So this is case 1. This whole syntax will be covered for the case 1. Now we have to go for the second case. So in the second case we have to initialize temp equals head. So let's do that now. Initialize temp equals head, and after that we have to traverse to the end of the linked list with the temp pointer. So I'm going to use a while loop. So let's make the command as traverse to the end of list. Now in the while loop, while temp dot next not equals null, I'm going to point the temp to the next element. So temp will be temp dot next. So temp will be pointing to the next element. So temp equals temp dot next. So this will do the operation until it reaches the end of the linked list. So when you say temp dot next not equal to null, so this is temp means temp dot next initially, that is not equal to null. So here if you say means it will be not equal to null. So when you say temp dot next, so currently temp has some next element, so this condition is passed, so it is not equal to null only. So it will do the operation once, so it will be here, and it will do the operation again, it will be here. When you see the original list, it has null value. So when the loop breaks, I am going to assign temp dot next equals new node. Temp dot next equals new node. That is the node we are connecting here. So temp dot next will be the new node. And finally we will be returning head. So return head. So as usual we didn't touch anything in the head pointer, so it's not matter here. But if the list is empty means you have to return the head pointer because there will be some address here, and this is the whole algorithm. So let us place it here. So this is somewhat a bigger algorithm for us because I left some space. So I'll just place it here, and I think this will be much clear for you. Let's quickly review the algorithm now. First, we are going to initialize the new node with the help of the node class and with the element that we have to insert. Here the element is 3. Now for the first case, if the list is empty and we are just checking for the condition if head is null, we are going to assign the new node as head. So that will be here. We have assigned the new node as head. And in the second case, the list has some elements, means we are going to initialize temp equals head. So we don't want to change this head pointer. We are going to traverse to the end of the linked list. So using the temp, using this temp.next, we are going to traverse until it reaches the end. So after reaching the end, we are going to assign temp.next equals new node. So this is temp and dot next is the new node. And finally, after inserting the element, we will return the head pointer. And that's how the algorithm works. And that's it, guys. If you have any queries related to this videos and you have any doubts, means please leave a comment below. Apart from that, if this video is helpful to you, hit the like button and don't forget to subscribe the channel and share the video to your friends if this is helpful. I will see you guys in the next video.